Hey, welcome to Cloud Unplugged. Today we're going to be talking about GitOps, the infamous phrase used everywhere. Means slightly different things to different people. But do you both want to intro yourselves and give a little bit of background about what you know about GitOps as a little early starter, and then we'll kind of get into it. Mark?
So I guess I'm Mark Hughes. I'm now product engineering manager at Appvia, but throughout the last 20 years of my career has been a slow journey towards commit everything, put it all in repos, control the source, control the workflows, get it all repeatable. And it's interesting to think about where we've gone with that and whether we've gone perhaps a little too far.
Yes, I'm Lewis Marshall. I'm a small part founder of Appvia, and I've worked with Mark for many, many years, and part of that journey for the last decade and a half, thinking about software delivery and DevOps practices, and more recently, more development. But yes, I've certainly been encouraging Mark to make sure that everything's repeatable and testable, and you absolutely do want an agile process which is test driven and all committed. But yes,
wow, I feel like this is building into a little fight going on. It's like,
we're getting ready.
Basically, you forced Mark down the path of GitOps.
He really did.
I mean,
it's sort of he is effectively
it's a safe space. So
the priest, if you like, and I am the started out in the back pews as an unconvinced sort of minion and slowly worked forward to the choir where I am now, fully singing from the Commit Everything hymn book. But I still think there is nuance here, and it's worth exploring.
Yeah, I guess one is probably GitOps, and then a little bit of the semantics of, I guess, what that means to people, because when you say it, people just think instantly of certain tools, which is maybe a slightly clever marketing campaign, or really it was like fundamentally something that made sense. Who knows? I think the principles, though, of doing things in Git, yes, obviously the same reasons probably you'd want to do most things in Git. That's anything to do with code and like oversight of what's happening and changes that are being made as configuration or code. People need that. But the operational part of the Git, which is we'll use it to operate your estate, essentially is really what it's saying. And I guess manage all different variants, elements of state, that things obviously have a life cycle, production being usually the end part of the life cycle. And then there's everything from test all the way in between that, which Git isn't designed for, which seems slightly strange to try and use it for something that it's got no sense of your like environmental state, of which is all variant maybe, and supposed to be slightly different for legitimate reasons, cost and etc. So that bit I find slightly strange, but as a model, I guess I'm just throwing that little grenade in there on thoughts to get the conversation going.
I think for me, the great thing about the model of committing it all is knowing the rebuildability and predictability of it. Like, you've got your process checked in, you've got your definitions checked in, you've got your config checked in, and you pull that together and get a defined outcome, and you know it's repeatable, which is good. But then to talk to the point you just raised of the different environments and how you roll that through different environments, it feels to me like we've gone off the right path there, where we're you end up with this sort of model of different branches in your repository representing different environments, and you sort of see how that at a small scale it makes sense. You're like, okay, I'll merge from my test to my dev to my pre-prod to my prod, and it sort of starts to make sense. And then you sort of start to realize it's like, yeah, but what about the things that are always different in prod from dev? Are they different branches of the same file, or are they different files? Because they're different things, and if they're different things, that means you can never really reconcile those branches. They're not branches anymore, they're folders in a file tree. And somehow the model just, like, it doesn't quite it doesn't quite map to the reality of the problem space you're trying to solve anymore. So you end up tying yourself in gymnastics to make that work.
Come on, Lewis, you're going to put up with that. Come on.
I'm not, no. I think it's worth defining some terms at this point, maybe, about what GitOps is. So Mark's definitely using the sort of generic terms around GitOps, everything in source, and coming up with some crazy branching strategies here around configuration. But, that's all fine. And if you're just speaking about configuration in a general sense, that's one thing. GitOps in more recent years has come to mean something in relation to Kubernetes and certain tools that have been donated to the CNCF, Flux, and closed source tools that are also in this space, Argo CD, that enable an outcome defined by Git to be pulled into a resulting environment.
So play devil's advocate. If I don't use Kubernetes, I can't do GitOps. Is that what you're saying?
I think the nomenclature, the most modern tip of the nomenclature around GitOps certainly would suggest that it's relating to Kubernetes. But in the general term,
I felt it was a really good political.
I know.
That was quite impressive.
It's like I've been trained or something.
I'm pretty sure I was introduced to the word GitOps before Kubernetes was even a thing. Like, I reckon that term was certainly the
infrastructure as
concept
code, definitely.
But the concept of like configuration management in tooling, in source control, like that. It was a growing art. It's come over the last sort of 10, 15 years where that's become more and more of a thing. But I'm sure I heard the term GitOps well before the modern incarnation of it as a pool-based Kubernetes operator.
I think you're absolutely right. That the term operations led by Git operations and shortened to GitOps, I think is a very clever bit of marketing, you could say, and maybe on one extreme. The other would be a community that have formed around the CNCF to define GitOps as this thing around the CNCF golden child of Kubernetes. So yes, there's definitely a bit of nomenclature these days around the term.
There's the open GitOps thing. I don't know enough about that in detail to know where that stands, but I'm sure it would mention like some principles around it. Obviously, it has to be Git, it has to be declarative. I think it mentioned like it being reconciled. It's a pull model, like all these types of things, which then go to your point in, most of that pretty much describes Kubernetes and an agent running in Kubernetes. So if you're then a mixed estate, and you're like, well, not everything of my state runs in Kubernetes. You're then like, well, are you doing GitOps when it's not Kubernetes then as an org? And that's a little bit confusing because you're like, as a paradigm, you're like, yeah, we do GitOps, but then only when it's Kubernetes.
It's a very good point, and it really does drive to the main difference between the modern term GitOps and a more traditional set of tooling. The biggest difference would be on the more traditional side, it's a CD type flow, a continuous deployment type flow, where the tool leads the change and the configuration at a point in time can be released to a particular place. And ideally, the same configuration with the smallest amount of change can be targeting different places so that you can use one set of definitions and be as dry as possible, so that's don't repeat yourself, and have the least amount of human error and surface area for change, so that you can have fair degree of certainty that what you release to environment A will be representative of what you release to production eventually. Now, with GitOps and the pull model, it turns the security and the access requirements on their head a bit, which feel maybe righter, that you don't have one place for your continuous development that would be able to have access to all your environments. That feels a bit, ooh, are you sure that's right? And then the pull model enables that security model for sure, but it almost works against that dryness. It's very hard to have the same thing go. And the tools have made big strides over the years, and most recently with using configuration and patching and all the relevant things, and tagging as the thing, not branches as the thing, to promote. But then you do want visibility, and you do want a traditional CD type approach for the actual visibility of when is this tag going to move and denote that change should apply to a new environment. And what assurance have you got that that is even representative if that's the case?
And to sort of continue on that, like, and when has that change happened? Like, when I intend to make a change, and it was very interesting at KubeCon last March when we were there and talking to various people. And for people with a development background, they were like, they couldn't get comfortable with this pull-based approach because they didn't know when their change had gone somewhere. And the people from the DevOps background were like, this is great. It all just sort of reconciles it out, and it's everywhere, which at massive scale is the right model. Absolutely. If you're trying to do something at world scale with thousands of clusters and you need them all to be consistent, but you can't do a single thing that pushes to all of them, it makes sense. But from a development team perspective, they find that model, it's jarring with the traditional CD flow, but there's a good reason for that, which is, at the end of a CD flow, has this change worked or not? Whereas with a sort of slow pull-based approach, you kind of eventually know whether it worked or not. You kind of eventually get a feeling that it's not worked, or eventually got a feeling that it worked. And you can obviously do things to mitigate that. And obviously with any tooling, you can design good processes around knowing health checks and knowing things have worked and knowing the percentage of your estate it's been rolled out to. So again, you can solve all those problems, but it makes it less natural to operate with for the people involved in the process, which makes them further removed from the outcome, which I think actually leads to worse outcomes. The sort of honeypot problem of a central CD. You talked about so many things. I'm going to go through all of them now. The honeypot problem of a central CD. Absolutely, it's a real problem. And think about how you segment that down into individual runners or whatever that are augmented and with the right authentication access to particular environments, particularly with all the OIDC flows and things like that you can do now. You can be very, very segmented about those access rights to help mitigate that in a different way. You sort of like, so it's sort of like there are other mitigations you can take to get that same kind of segmentation of your estate in a secure way. Yeah. I've lost track of all the other things you said.
But I think you've reminded me of a certain thing about the tip of the industry talking about CI/CD and Kubernetes, but the difference in the tooling. If you look at the more traditional thing, most environments aren't built using Kubernetes to build Kubernetes. I mean, I say most, but and on that front, the probably the most common way of building cloud infrastructure for certain is probably Terraform. And Terraform is very much a push approach where
with
state where it certainly doesn't reconcile over and over again, and the world may change. And typically when you move things into a promotional state, you can do all the checks you like, but then when you merge a pull request on Terraform, a often used pattern is to then apply the state after the merge. And all the providers are not quite equal, and all the HCL code that you may have written is not all equal, and your dependency tree may not be informative and may break and go snap, and you might need to apply it a few times. And then what's the state of your repo versus the world? So, it literally speaks to that problem of the repository not actually being representative of what you have released. It's just what you intended to release.
So if you're doing Terraform you don't do GitOps. So if you, so just understand,
you're operating Git. You're
just for the
applying your operation
just to
for
clarify the definitions of the industry here. If you're mixing, which most people do, you've probably got Terraform, right? Because some things just need it managing the policies of your cloud and building other cloud resources and all these other things. That ain't GitOps. But then you come to Kubernetes and you do that, and then you're like, well, that's GitOps. So if you're a developer who needs cloud modules, you won't be doing GitOps. But then when you then deploy your app, you are doing a bit of GitOps.
I think you're being churlish here. The first thing is operations in Git, and the second half is GitOps, and they're obviously different things.
They are very obviously different things. Sorry, silly me. Now you said it that way, I can clearly see why they are very different things.
Thank you, Mark. You made my point for me that there are definitely overlapping terms here, though, for sure. And Git operations with Git could be abbreviated as GitOps,
but it's very different.
But it's definitely been subverted with some, I say marketing again, but some clever messaging, let's say, around that term. And there are benefits on both sides. Having a push flow means you can verify, you can have tests, you can put them directly in line with the change and rollback flow. Whereas in the GitOps approach, you've then got to think very cleverly about, well, how do I undo that change and roll it back? I mean, it's definitely faithfully telling you exactly the state of your live environment, but is that live environment healthy? How do I apply further change?
I guess that's it, is it not, though, that I guess if it's operations, and that's what we're talking about,
for sure,
they usually fall into the category of non-functional requirements when you're developing software and things like that. So they aren't necessarily attributed to any of your functional code that you're writing. So, but then if you're into non-functional things, then you're into the team should have a fast feedback loop. They need to know when something needs to change quickly. They should be able to PR and fix things. I should be able to replicate an environment really, really, really fast to replicate production issues. I need to have assurance on things. I need backup. I need DR. All these things are all like scaling up properly and blah, blah, blah. So they're all like the non-functional. So if you put those on a list of does it give me the things that I feel are going to be productive for teams, which is, well, when the team applies a change, all the team can see that change didn't work, right? So if you put another PR in, I can see that PR should fix the thing I just saw that failed. But if I can't see that, there's no transparency on the team. How do I know?
I guess the point I was making is that regardless of the tool, I was talking about Terraform before, and poorly written, Terraform, but poorly written providers and data sources could lead to exactly the same outcome. You've got something merged, you haven't written the relevant tests or the relevant smoke tests or infrastructure, non-functional tests to know that the thing is actually working at the end of that pipeline, just as much as you don't necessarily have the visibility after changing something in GitOps. Regardless, you need a pipeline and a feedback loop. You have to know that at the end, you've got the relevant checks and balances to smoke test, to bleed production workloads into effect at the right cadence. These things are a wider problem than the tools.
True, but some things, I guess, if it's contractual, API, which is really what Terraform's about, so you're trying to configure something based on an API, it won't know what you're intending to do,
Absolutely
right?
not.
Because it's got no opinion of it.
Indeed.
However, if you did give something that wasn't conducive to what the API expected, it would error.
For sure.
If that happens with applying a deployment inside of Kubernetes, but it's also taken it already, and then it's running with it, then I don't necessarily know that the contract was broken because it's going to do it, not me. And that happens in some other stage somewhere on some reconciliation loop of a thing. It's not quite the same.
I'm not disagreeing.
Yeah.
And I think the some of the things that are solved using the modernist term of GitOps with the you can definitely guarantee the state is what you have. The biggest problems, other than the dry problem that I mentioned, are then the visibility and getting the feedback.
Yeah.
And those have to be engineered, and having a pipeline and promotion of those things, and making sure that you can't promote beyond, say, your development or your staging environment to get to production, and making sure it is the same set of things is much harder given that type of tool. It's not impossible, and people do it, but it's just a different set of tools.
I think the other problem I have with this sort of pool-based model and the sort of merging between different branches to promote, or even tagging to promote, that I have is it's harder to validate that thing before you merge a pull request, because it's harder to understand conceptually what the right validation is you can do at that point. And also, the model doesn't concentrate you on something. I can't remember who it was. I think it was you taught me many years ago about the right way of laying out your configuration. So what you want is the maximum amount possible of your configuration to be identical between the maximum number of environments, with only the very tiniest differences between the environments being what you have, because that is fundamentally the untestable part.
I put it as the surface area of human error.
Yeah, exactly.
That's the bit.
Yeah, so the IP address that the production environment uses or talks to, the actual domain name it's exposed on, those things that are completely
somewhere or
maybe
something,
they're completely environmental specific stuff that you can't replicate. And then everything else becomes shareable between the environments. So your pre-production can use 99% the same configuration as production. Now, the sort of branch-based model or merge-based model of promotion, because they're different branches and have their own lives, they can diverge on those things, and it doesn't drive you back together.
Because
go for it.
You would. So
you're going to anyway.
I am. I'm in the middle of it. I'm trying. The branch-based model is certainly not a model I would advocate.
Okay.
And tagging the same branch and having the tag being the thing that's pulled in. So you move your tag for dev forward, and then you put a pipeline to make sure where dev gets to can then be tagged as the other environment name. So you're pulling in based on a tag, which doesn't represent a version of your configuration. It labels an environment.
So you have a tag that's labeled as an environment?
Absolutely, yeah.
Isn't that just the same as a branch?
It's not quite, because you're expecting the same branch to move through and have the same information on it, and the delta on that branch is therefore hopefully the smallest amount of human error possible in some configuration or templating, which is now possible with these tools.
So in that model, what represents the difference between them? Is the production config available in the repo on all branches?
Absolutely.
Okay.
Absolutely. And you're literally trying to minimize the delta between them at all stages, and you've got to put additional effort into making a pipeline that sanctifies the promotion flow, so that you can't just put what happened to be on dev, the dev, wherever you've tagged dev, straight to prod. You need some other process and some CD, for example, to do that, to then test to make sure that after it went to dev, some sort of smoke testing happened, and you get that signal back to your CD process to then be able to continue the flow to say, this at dev passed that, and therefore I can promote on. So it becomes a CD problem rather than the pull model per se.
So to put it another way, you would advocate for something outside Git being the arbiter of what can go where.
Absolutely.
And then the production is told you're now following this tag.
Absolutely.
Okay.
But then,
so no, production is always following a tag called prod. So the tag becomes the name of the environment, and you re-tag the repo on the main branch on what's merged to move it forward.
I'm just going to say at this point,
it's totally not software control.
The developer in me
way.
Is like,
I know,
tagging what?
You're absolutely right, and it really is an abuse of Git at this point. In every bit of your deep DNA that goes like,
so
how
you're
do I assure
force
what
pushing
the thing
over
is?
the tag?
No,
You
after the merge. So prior to merge, all you can do is linting. Really, you could have other environments that have arbitrarily tagging your dev on your ephemeral environment. Could say ephemeral 1, and that's where it goes from. And then you merge to main, and your dev would typically always reflect the main branch.
But you would still tag main. You'd
still
tag
as
it
dev
to be dev,
to concrete it at that point. And then you would have a pipeline that can also tag prod after you're sure that
so if dev has gone well, then maybe create a new tag called prod
on the same location.
But
as
what
dev.
is it? Just regex matching on something, whatever it is, -prod. Like, how does it know which tag that's labeled prod?
So if we're talking in a specific tooling like Flux,
yeah,
you get the when you bootstrap your cluster, you point it to your repo, and you can follow a source ref or a tag or a branch, right? So you would get it to follow a tag.
But then that tag
would
never
always
changes.
be called prod. It never changes, and you just move the tag along.
But you can't. How do you
in
move
a pipeline?
But
your
it's looking
CD
at only
process.
one. It's looking at a point in time that
delete-
should never change. That's the point of a tag.
No, you can delete a tag and retag.
You retag.
It's that wonderful thing about Git as a source control
So you're going to
system.
delete a tag which is a history
Which
point
is
of
why
time,
it
and then
really
recreate
makes
another point of
your
history.
developer DNA feelings really get hurt by
Wow.
good
I
practice.
mean, git push -d tag, it goes.
Yeah, no,
You
I know
just
that.
Tag it
but
again.
The whole point of the tag
but you're
was
going to
that
have to
it
have
was its own
different-
point of time.
You're going to have different process and controls around the promotion rather than what's watching what. It's a less evil thing than trying to say your branches are all different. You've got to merge madly between them and try and work out the delta there.
It does feel much less evil.
And much less evil for...
I mean, it's evil against the principles of Git rather than evil against
Absolutely.
like, almost human rights.
Yeah, or human rights in DNA regarding developer workflows. It's the opposite of that.
Didn't you
Absolutely.
do something recently where there was also customizing the mix for the differences between the environments layered by some Flux?
So in the past,
Of which there was a
for
base of a-
Flux as a case in point, in the past, it used to be the personification of anti-dry. I mean, it was the wettest thing in the world. You'd have a customized file and a patch set which led to like a bazillion files long for each and every environment. And whether you kept them on different branches or up your sleeves, it really didn't matter at that point. And your what is the smallest amount of change was a problem. But the tools have moved on a lot, and they have recognized that actually you probably want the base to be almost identical in all cases, and
Like
the
common
layers.
things, basically.
Yeah,
Like, what's
exactly.
the common denominator between everything?
And you could feed in some configuration constants for that environment to say these are the things that are known to this environment and are constants, and they could be provided by, I don't know, Terraform, for example.
Sorry, I'm thinking more though the relationship between the two of like you've got a model of trying to keep consistency using so whatever it's Flux, whatever it is, but something that's watching a branch,
A tag.
whatever. They're the same thing.
Whatever.
They all point to a commit, right, at the end of the day.
Yeah.
A point in time of history, whether it's a branch or whether it's the tag.
Yeah.
You know, if you want to pretend that history didn't happen and replace it with a new form of history, whatever. That's what we're going with. Apparently. So anyway, that aside, there's then the bits of configuration that is legitimately supposed to be different. Now you're saying where do those differences get handled? So say I've got different levels of scale, and I'm like, well, actually, this needs to scale differently. It's got,
I'll explain. So in the case of Flux, there are many different ways of doing this for sure, and I'm just going on recent investigations and latest updates, I guess, in the industry. You typically bootstrap a cluster with following a repo, add a tag, and the environment name. So the entry point to the repo will be the environment name, the name of the cluster, for example. So it could be dev following the dev tag. So its entry point will be all the customizations that are specific to your cluster. And that could just be, we're going to put in this config map, and then all the other things are going to just read and use that config map as environment variables. Or they could be literally all the patches to all the things downstream from that cluster. So if you had lots of manifests that were identical between dev, prod, then the scale size or the cost or the region or the amount of replicas could all be configured for each environment and would be overlays and patches from that place on your base. But there'd be a
different environment that is then in that tag.
So it's only the patches that would be different.
Yeah, but those patches that are going to
be entry point.
But the patches you're talking about customize at that point.
Yeah.
When you talk about patches, so that's what I'm saying. Flux doesn't give you the mechanism of making the differences. You're using another tool.
Well, no, actually, it natively supports customize.
It does,
how it does it.
Thing.
So that's how you use it. It natively supports it at the server to patch your resources using customized syntax.
I understand, but that's another thing doing it.
Absolutely,
it's not
well,
Flux.
It's actually the customized library in the Flux.
True,
controller.
But it's the library of customized doing it, which is then another thing that you've got to understand. I mean, on top of the thing you've just got. So then you've got Flux, and then you're going to have to do the customize, and then you've got the.
I'm not saying it's not complicated. It is about as complicated as it can get. But there again, the industry is not great at keeping it simple. If you're talking about providers for HCL,
So
now I'm just trying to understand the layers of the layers of the layers.
Yeah, there are. There are about 5 of the layers on the layers that make that thing come to true.
One of the things that's kind of bothering me about this whole thing.
Just one.
Just one. Is the kind of bifurcation of many different repositories being involved in any element of change. Now, I've got this kind of ultra idealistic ideal that you should only have 1 or at most 2 repositories for any entire stack. One for maybe the infra, one for the software itself, and the 2 of those should come together in a beautiful flow to make every environment you could possibly need, ephemeral, production, and everything in between. Now, what I keep hearing from people when I talk to them at industry events and things like that is it's like 7, 8, 9 different repos. They have to synchronize pull requests on them all to get that. So this wonderful thing you've just described and this terrible problem of 9 different repositories, where are people going wrong in where they end up with so many different things they have to configure to make their infrastructure and their app work?
So when I was saying about the entry points, it takes a lot of planning. And it's very complicated to get a single entry point.
Just to clarify the question, sorry, a little bit though, is to add context to why you would have 9 repositories, I suppose, is you're not talking about application, like development teams, like there's 9 teams.
Absolutely no.
What you're now talking about
for a single app.
There is lots of different things going into the cluster that all need configurations to come together.
It's like everything that makes that app's stack work is what I'm thinking the scope here. So it's like the cloud infrastructure that the app's running on, if that's got a cluster in it, the configuration of that cluster pre-app for the non-functional requirements,
the dependencies it might have, like ingress, certificates, all that stuff.
And then the app itself. And with the deployment of the app and the app itself. So you kind of got those kind of different layers that get involved.
And then the touch points between those two, with obviously the app needs to know about those things that have gone in the cluster in order to get the relevance of their automation around those things. So there's a relationship between them. So then you've got different teams doing different things with loads of repos somewhere, and then the teams trying to also then deploy things into these clusters.
And often one team is having 4 or 5 different repositories involved in this game. It's not just like one app, one repo per team.
I suppose the reason you have a different repository and the reason you use Git is to have a rate of change, like in a unit, a unit of a rate of change. So if you were going to have the source code for your application, have that in one place and then promote its things to like artifacts of some sort, the outputs of your build process. And then you would maybe then refer to some of those artifacts in your CD processes that would then promote those particular given fixed artifacts at certain revisions through a set of infrastructure repositories that would then, make these things real. Now, what I was describing was a single repository that would have the rate of change for your application, for a cluster to be configured. But undoubtedly, you're going to have multiple teams and different rates of change. So if you were talking about Cert Manager and other cluster or entire organization-wide concerns where you may have a platform team, they may want to have a different rate of change for those shared bits to those applications. So then you've got another repo. So
because obviously we kind of know about the industry tooling, you kind of do things. We are trying to address this problem anyway, I suppose. But our view of it is there's got to be a contract in place between what the developers' applications are expecting and what is in there, and whether or not it can facilitate the ask. If those things are just moving, right, independently on these tags that are kind of going on in a promotional thing, and there's supposed to be a contract between an application running in that cluster that's trying to consume these services, I don't quite understand the detachment of that relationship, as if it doesn't have any consequential element to something that runs in it.
I concur entirely,
Right.
and I
It
agree.
a little bit.
But I think it's a bit like the Linux ideals of it, like you make sure a tool does one really tiny thing really well in isolation. But then the problem you've got is a big Red Hat sort of integration problem of getting a distribution together of all the things.
You can do one thing, though. You can do one thing really well, but the rule of thumb is the minute somebody's consuming you, you need to always support it in that point of time that it consumes you, because you don't get to control how it's decided to consume you and the library that it's using to consume you. So the minute that happens, there's then a contract, as APIs do, and there's backwards compatibility and there's versioned APIs, and all of those things exist for exactly those reasons. And this feels a little bit strange because it's like you've kind of got an API, right, extended inside of Kubernetes for these services. So there should, in principle, be a contract, but it may or may not be backwards compatible, and it also could be moving. And it's then like, and also whether it's moved, well, maybe you do, maybe you don't. It's moved.
It's sort of how you form a system or a workflow that's got the right contract between that sort of set of responsibilities of team A, call them the platform team, and the set of responsibilities of team B, call them an app team. And how can the platform team express that in a contractual way where they can deliver infrastructure repeatably and reliably and testably, and yet the app doesn't need to know about the 9 different tags it needs to pull into its cluster. It's a deterministic thing that they can rely on for their app and test their app against as they roll it through environments.
This almost sounds like we're coming up with a solution in this space of.
But I do find it interesting,
need to make sure these things.
I guess, irrespective of kind of like what we do, I mean, the principles, like what I've just described, isn't new. No. So what I'm a little bit kind of confused by is how things that we know exist as standards can then not be met in what is deemed supposed to be like ways of working and engineering best practices. And so it's kind of a little bit ironic that you'd give a standard on one hand called GitOps and not meet another standard called API contracts on the other hand. So it seems slightly bizarre, in based on the principles and best practices. Is like, well, you expect those things to also be in place, or it needs really thinking about of like, well, fine if it's just an isolated thing that is allowed to move in its own right, and like absolutely it should be able to. But the minute there starts to be dependencies between things, then that's a little bit of a different game, and that's harder to.
I wouldn't say it's necessarily solved with CD or push or GitOps or any of them, though. I'd say all of these things are very thwart, but I agree entirely that because the model,
because what we said before is when you are instantiating the outcome, and it's not, I guess, deterministically going to happen potentially in the future, whether it worked, then when you instantiate the outcome, like it's this version of this thing that goes with this version of this thing, and that needs to all work together. Done, go. And then it's like, blah, 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 no, it won't, didn't work. All right, cool, fix it. But instead it's like,
I guess on the one
go
hand,
and who knows what happens, and then I'll go and find another process. And because of that, then it makes it harder to validate. You're
absolutely right. But I mean, I remember way back in the day when we were working together at the Home Office, I believe it was, when we were looking at eventual consistency with CD and Kubernetes per se, you know. kubectl apply, boom, done, right? Eventual consistent, well, did it work? I don't know, kubectl has got a 0 error code, so it's all good, right? So that's a CD model, there's an API, it met the API, was the outcome good? No, it was all flapping, it didn't have the right image, there were no replicas, and it was all dead. So we wrote a tool to actually go and follow the thing and make sure the blooming thing came true and would tell your CD that it had failed. Yeah. So it doesn't matter, it's more about the controls that you put on the tooling to make sure that actually the outcome and the contracts mean something to a developer. Because really you want to do tests at the end of it as well. Because even if the API has accepted it and the workloads say that they were running by that API, were they actually still functionally accurate, or did you have...
Is it actually working?
Did you forget the volume or get it wrong, or set the memory to 0
or
and
deploy a
and
version
have it
of your
crash
app that doesn't work?
Or deploy the wrong version. I mean, who knows? Yeah, so you've kind of got to have other safety checks regardless of the process. But yeah, the process is certainly... I guess the pros of a push model is that the process is in line at least.
But it's just like a lot of everything's got a compromise. I understand. There isn't always going to be one answer to the problems that are all slightly different problems. But I think when there are teams working in slightly different ways potentially, and in the model you said, that makes a lot of sense because I'm in control of releasing this thing, and my assumption is that it will work. Right, but I'm only in control of the thing I'm managing. If it worked on a version of something I can't see underneath, i.e. Cert Manager, then my assumption is it will always work. Mm-hmm. However, if somebody then moves Cert Manager behind me to another version, I can't test that. Mm-hmm. Where do I test that? Suddenly it's like that's not part of my stack, and it's not validated.
You're right, but I think that's a case of if you've got many repos, regardless of the process to make them effect, if one team, the platform team for say, is playing with Cert Manager and updating that with their own CD process, and you're updating the app with your CD process, where you've got that problem again. So you're absolutely right. The real thing is having a better contract between what the application depends on and how you validate that that's met.
I think for me the beautiful model of a Docker file for your infrastructure, that kind of getting to that point where you can have a contract of this is exactly the layers that make up my infrastructure, and committing it all into a Git repository gives you some of that and the right tool to pull that together, and to know from an app team like this version of the infrastructure gives me a known outcome and my app works and all the things it needs works is a beautiful place to be.
Absolutely. I mean, having a contract that can be met on both sides so that there's assurances and knowledge from one team that you're not going to affect the other team would be the ideal to strive for in this space, for sure. Not simple.
Yeah.
But we wrestle with it.
I mean, we didn't really solve anything, but hey, it's great to throw rocks, right?
Those windows wanted smashing.
Exactly. Smash some windows.
Let's hack at some golden cows.
Exactly. And then basically, then pretend that we don't really have that. Anyway, great as always, and thanks for coming on. And we shall speak to everyone soon.
Thanks for having us.
Thank you.
It's good fun.